Alright, due to popular demand, here is a debugging video for Microsoft Visual C++ Express. In this video, I'm going to show you how to set breakpoints, how to use the watch window to view the contents of variables and memory locations, and the locations of variables in memory. I'm also going to discuss a little bit about the address of operator, and we'll talk about debugging a function and maybe passing back and forth a string from back and forth to a function. So before we get started, I've got a just a simple main program with an integer declared. Some very simple program where we're going to ask the user from the console window to enter the integer number. Going to scan for that number and write it back out. So this is where we'll start from. And at the end, this section, all it is again is to basically hang the console window so that we can see the program before it exits. What we've done in the past is just run this, and if it didn't work, well, then we'd try and change something and run it again. So let's try it right now. And of course, this should work. So if I enter the number 56, oh, you entered 56. Hey, that's great. So what if something comes off the rails in the middle here? What if I put integer number 1 and int number 2? And in here, I want to read in integer number 1, and I'm going to write out integer number 2. And just for fun, I'm going to declare these as 0. Oh, pardon me, I'll put this as 1 and 2, which really doesn't change the program. It just will alleviate some of the warnings we would have got otherwise. So let's run it. And so we built it. We're going to run it. So what happens here? I'm going to put in the number 5 when I get out the number 2. Curious. What did I do wrong? How do I figure it out? Of course, this is a very simple program. You could just look at it and figure it out. But what if I couldn't? What I can do is I can put a breakpoint in by single clicking in the left-hand margin, and I can stop where it's time to enter the value in. Or I can stop after I've already entered the value in. So if I put the breakpoint in and strike F5, this will run the program up until the breakpoint. So I'm waiting for a number. I'm going to put number 6. Oh, it stops. What's going on? If you notice, the window at the bottom here, or the tab at the bottom, was blinking, which means control's been passed back to the program. So now I've actually stopped at the breakpoint. And now I could, if I had a watch window open, I could view what was in those variables. So I want to see what's in variable number 1, int number. So if I go down to the bottom here, there will be a number of windows that are up. If these are not up, you need to go to Debug, Windows, and then go to Watch. And it'll show Watch 1. If we remove the breakpoint and run our program, we actually can't have a watch window. Your program needs to be stopped by a breakpoint in order to have a watch window. So anyway, in this, I want to have integer number 1. So what I can do is I can highlight integer number 1, right-click on it, and then say Add Watch, and it'll automatically add it to the window. And since I've already entered 6 in the console window, 6 appears down here. And I want to have int number 2 there as well. So I'm going to right-click on that, and I could add it the same way by adding watch. But otherwise, what you can do is double-click in the watch window and just say int, and actually type in the variable name, number 2. And it comes up as 2 because I had already pre-assigned it at 2 up here, and I haven't changed it. And hopefully at this point you'd figure out what the problem is. What I can also do down here is I can view where int number is stored in memory by putting address of operator right in the watch window. And I can say int underscore number, enter. Oh, int underscore number 1, enter. And now it actually gives me the memory location of where that value is stored in memory. And what it does is automatically brings up the value that's stored at that location in memory. So this actually includes the address as well as the value, whereas up here I only had the value. So I could, in fact, highlight this entire thing and say add to watch and get the same result. And either way is fine. It's just sometimes nice to have the address there as well. And we'll see why that's important as we go farther along in our programming. Okay, so the important things to take away from this are that you need to have a breakpoint, and your program needs to have stopped at a breakpoint in order to be able to view variables in a watch window. Okay, once you've stopped at a breakpoint, to start your program running again, it's a good idea, if you've stopped at a, say, a printf or a scanf, one of the built-in functions in the C language, it's a good idea to use F5 to start your program again rather than using F11 to step through your program, and I'll show you why. If I put another breakpoint here, and let's say I just want to step, if I go down here, I can say step into, step over, step out, etc. If I decide to go step into, which is a common single step in debugging, what's going to happen is it's going to go into the printf function. So if you watch, I go into this code that I haven't written, and I'm not sure exactly how this is operating without giving it lots of thought. Okay, so the only way to get out of this now is to press F5, and it'll run back to the next breakpoint. So again, F5 will continue or basically run until you hit a breakpoint. F11 will single step each line of code. F10 will actually step over all of those built-in functions. Okay, so or any function for that matter. So for example, let's try and run this program again. So I'm going to build it, and you say yes, stop debugging. I'm going to run up to the breakpoint with F5. So I got to enter a number. Okay, and notice the window down here was blinking, or the tab down here was blinking, which means that I've returned control down here. And of course I entered the number 78, so that's in here, and 78 is in the address where the int number is stored. Now if I press F10 instead of F11 at this breakpoint, it will jump over the printf, the details of the printf function, let's say that, or the function call, and it'll come right out to our program. So F10 is a much better use of the debug stepping. And if I hit the bottom, if it says, I say F10 at the bottom, it will wait for me to press a value in there. Wait for me to press a value in the console window before it exits. So again, summarize. Things to take away: you need to have a breakpoint in order to see the watch window. Your program needs to run in order to see the watch window. It needs to run up to the breakpoint. Once you hit the breakpoint, a good idea, if you don't want to see the details of the built-in C functions, would be to F10 step over the C built-in functions. If you want to see the details of your own function, you would need to use F11 to step into the function. And let's see how that's going to work. So let's say, for example, I actually wanted to get this integer in a function instead. So I'm going to go down here, and I wanted to return a function. So if I want to return something from a function, the function definition needs to start with the type of variable I'm returning. So I'm going to say int, and then I'll say get an integer. And I'm not going to pass anything into the function. Okay, all I want to do is return something. So I'm going to take these things that I had up here, cut them out, copy them down here, paste them in, and I'm actually going to, I'm not going to copy all of them. I'm going to keep the printf up here. But I also need a function call. And in fact, I'm going to get rid of this int number 2 at this point because I don't need it anymore. But now I'm going to have a function call, and I want to return int number 1. And then up here, I need to make the function prototype the exact same as the function first line in the function definition with a semicolon. And in here, when I call it, I actually need to set the function call equal to something because I want to return a variable. So I go int number 1 equals, and then the function call get an integer. Okay, so now when I run this, it should actually get the integer from the function and return it into integer number variable. And then it'll display it out properly. Okay, so at this point, have we missed anything is the question. Let's try running it and see. Or pardon me, let's try compiling it and see. Oh, looks like we have some errors. Undeclared identifier, and that happens in the function. Anytime you want to pass something back from a function, you need to declare a variable. So I need to say here int, let's just call it number in here, because it doesn't have to be the same name. So in here, then, I just want to call it number. And in here, I want to call it number. Before I actually return, though, I'm going to put a breakpoint in here so we can view a couple of things as we're going through. So let's try and build it again. Okay, so it's happy this time, and now we'll run using F5. Please enter an integer. I'm going to put 55. Enter. So now it stops here. So in our watch window that we had before, you'll notice that int number 1 produces an error. Int number 2 produces an error, and these other ones as well that produce errors. The reason is, first, int number 2 doesn't exist anymore in the program, so we can get rid of that. We'll get rid of these for now. Int number 1 produces an error because it does not exist in this function. The variable is local to main. Once you come into the integer, it does not exist. So I can leave it in the watch window, but I can't see anything in it right now. But if I add number to the watch window, then I can see, oh, I've entered the value 55. So that's great. Now if I return back to main, just by hitting F10 or F11, doesn't matter at this point. Now, if I step to where, just past where I've called the function, now int number 1 equals 55. So it does get returned, and you can see down here that number now is grayed out, and it says anyway, here's what it should do. So I've refreshed it, and now it produces an error because that variable does not actually exist in main, and that's where the current execution of the program is, in main. We've moved out of the function, we've returned, and we're back into main, so that variable doesn't exist anymore. Okay, so let's try and run this again. We've got both of those declared. Let's also put the address of operator. So we'll put the address of operator and int underscore number 1, and we'll put address of number, and we will get rid of this, and we'll get rid of this for now. And once I actually run to the function, this should be able to drop down to see what's in that memory location. Okay, so we'll finish running our program here and start fresh. So I'm going to hit F7 just to make sure it's fresh, and we hit F5 to run the program. So this says please enter an integer number, so let's put in 15 this time for fun. And oops, I forgot to put any breakpoints in. So before we start, let's break at the function call, and let's break after we've read the variable. Okay, so let's run again. So now I break at this point and it shows an address here. So that address is 0025F7E0. Okay, so hopefully that doesn't disappear when we go into the function. But now if I want to step into the function, I could do basically one thing if I want to just step into the function, and that's press F10. If I press F11, oh, pardon me, it's F11. If I press F10, it will actually try and step over the function. The fact that you have a scanf will mean it'll stop at the console window, and I also have a breakpoint in there, so it will stop. But if I didn't have the breakpoint in the function, it would try and step right over the function and jump right to the printf if I pressed F10. So in order to go into the function, I need to press F11. So one thing you'll note, and I'm glad this stayed up in gray, is that the address of int number 1 in main is 25F7E0. The address of number in the function is 25F700. They're actually stored at different locations. I haven't put the value in yet, so I'm going to do that. I'm just going to hit F5 to just run the program. And when I do that, this comes up. I put 63, enter, stops. I have 63 for the number in the function. That's what's stored at the address of number. So this is the address, and this is the value stored at that address. In main, I can't see what those values are right now because I'm not in main. If I put a breakpoint in main, just at the print, and then I press F5 to run to that breakpoint, it stops, and now 63 has been copied into int number 1, but it's still at a different address than it was in the function. Okay, so that's very important. So, summarize for this one. If you would like to step into a function when you've stopped at the function call, if there's no breakpoint in the function but you want to step through one line of code at a time, you need to press F10. Okay, and that means that means press F11. That means step into the function. Okay, step over, we'll try and step over a function. So just be cautious of those two. The addresses are not necessarily the same as in this case, we've declared a variable int number 1. It's assigned some memory. But when I go into the function, that memory location may or may not be the same when I assign another variable. And likely it's obviously not because I'm assigning another variable. It's not the same variable. But when I return it, I'm placing it into the same memory location as the variable I declared in main. Okay, so let's try this maybe a little bit more. Let's have a little bit more complication here. We'll add the character string called name, and let's see if we can pass that character string into the function. Okay, we'll say something like, in here we'll say something like hi, and then we'll write out that string, and then we'll say please enter an integer number. So down here I've got to put something to do with the string. Okay, so how do we declare that? We actually want to pass something into the function. So let's get rid of these breakpoints here. We want to pass something into the function. And what do we pass if we're going to pass a string or any array for that matter? What we pass into the function is the address of where that location, or pardon me, where that array is stored in memory. The starting address of where that array is stored in memory. So that means here, first I need to define this as a character array, and I'll just call it name. And I need to put square brackets. I'd never put a number in there, at least not for now with a single dimensional array. And when I call it, I've got a character name array, and it's already assigned. And in order to send the address of the first location, I just put the array name. Okay, you just put the array name, and for any array that always means the starting location of the array in memory. So down here, of course, this needs to be the same as the function prototype. And in order to write the string out, I use the address of where that string is stored in memory. So if all this is right, it should work. Let's try and compile it and see what happens. Yes, we want to stop debugging. Okay, so it built fine. We're going to put a breakpoint in here so we can see where this is in memory and how that relates to where it is in memory in the function. Okay, so once I get to the function, I'm also going to put a breakpoint here. So let's run this with F5. And we should get to our breakpoint right away, and let's put name into here. So we see the starting location. If you expand this, you can see all the elements of the array. Okay. I don't really want to see that. What I'm really interested now is this 21FD08. And in fact, in order to see this, we're going to change our program slightly. In the function, we're going to call this name F. So I got to change that throughout the function and in the prototype. And the reason is, if it's a different name, you're going to see it still has the same starting location. Okay, so let's actually build this again and try and start over here. So F7 to rebuild. Still succeeded. F5 to run. And let's see what happens here. We've got name. We've got an address of 33F720. And then let's put name F in here. Okay, obviously we're not in the function yet, so we can't see that. But if I press F5 to run to the function, you should see that these locations of name and name F are identical. And the reason is, all I've done is pass the address of where the array is going to be stored or used from to the function. That's how we pass arrays back and forth. We only pass a pointer to where the function starts in memory. And in the function, it might have a different name, but it goes to the same location in memory. So now if I run, I should see, hi Anthony, please enter an integer number, 55, and number's 55, and we are finished. Okay, so to summarize the last part, when we're passing an array into a function, if we want to populate that array in the function, or if we want to just write the array out in the function to the console window, all we need to do is pass the address of the starting location in memory. So, for example, if I wanted to overwrite the array name, I could do that here because I'm going to write it over the same location in memory. And I've printed it out as the same location in memory from what was set up in the main program. Hope this helps. You have to do a little bit of practice with breakpoints and watch windows to see everything you need to see, and if you get really good at it, you should have no problem fixing all of your runtime errors. Hope you guys have fun.